This ramp has lots of mechanical advantage, so it's easier for me to run up it than it would be to climb straight up it with a ladder.
The Doppler effect is the apparent change in frequency based on the location of the object traveling to the listener.
Like cars driving on the road,
Nobody cares
and you're
about
listening
cars.
to them, like that car over there.
Like right now? Oh, alright. Force equals mass times acceleration. If I wanted to get my weight, I would have to get my mass and multiply it by the force of gravity. Then I would have my weight. John is not doing any work because he is not moving. For John to do work, he has to move. The higher this is, the more potential energy. The lower it is, the less potential energy. If I had more weight, it would also have more potential energy.
Alright, so normal force is acting down on me because I'm not getting crushed by the gravitational force pushing down. If we didn't have as much gravitational force, I'd be floating away, and if we had more normal force, I'd be getting crushed right now. Air force is like I'm falling out of a plane, and the air is resisting me to stop, so I'm like slowing down a little bit. Frictional force would be like me sliding my bag, and it stops it. Tension force is me like pulling on a rope, you know, hanging on the rope, something like that. Yeah, that's it.
Alright, so let's say I want to take class quick. What do I have to do? Well, speed equals distance divided by time. So I'd have to get my distance done in a short amount of time. So if I'm going slow, I'm not going to have I'm going to have a longer time, so it's going to be a slower speed. If I get there faster, then I'll have a faster speed.
The electrons from my hair are leaving my hair and going into the paper, and because I'm charging the paper with friction.
Alright, so say I'm walking in one direction for a set amount of time. With the direction, say I'm going 5 meters west. That'd be vector quantity since it has a direction. But if I'm walking around in circles and whatnot, going directions, that would be distance, which is a scalar quantity.
As you see, the pencil looks like it's bent because the light travels faster through air and it'll travel slower through water, making it appear like it's bending because of the way that we see it, because of refraction.